Hi everyone. Today we're going to study graphs of quadratic functions given the standard form of a quadratic function. Let us now identify quadratic function in standard form. The standard form of a quadratic function is f of x equals a times the quantity square of x minus h, then plus k. We know that the graph of a quadratic function is a parabola. In the standard form, we can see here the h and the k, and that is exactly the vertex of the parabola. Also, this a gives a very special idea. The parabola opens upward when this a is positive, or the parabola opens downward when this a is negative. Let's have an example. Sketch the graph of the function f of x equals negative 3 times the quantity square of x plus 2 plus 4, and find the following. Letter A, vertex. B, axis of symmetry. C, range. D, maximum or minimum value. E, decreasing interval. And F, increasing interval. From the standard form of the quadratic function, as written here, we can collect the vertex immediately. However, let us make sure that the given function must be in the standard form, or we may rewrite the given function into the same way with our standard form, and it will be like this. We are going to copy exactly the same except in this plus 2. Since the standard form is written minus h, we are going to rewrite this plus 2 into negative of negative 2. And the rest of the function will be same. And from here, we're going to collect now the vertex or the hk values. So this negative 2 is the h and the positive 4 is the k. Therefore, the vertex has the ordered pair negative 2, 4. And then this negative 3 is the a. And since our a here is negative, it means the parabola opens downward. So let us copy the vertex opposite this letter a, and we will take note that the parabola opens downward here. Then let us clear the right side of the screen. Since the vertex is known, and we know that the parabola opens downward, we can now draw the parabola. So we have a parabola here that opens downward, and the vertex is the highest point. That is now the point negative 2, 4. Now letter B, for the axis of symmetry, it is the vertical line that passes through the vertex. And our formula is x equals h. And this h is the x coordinate of the vertex itself. So we will just substitute the value. So here the h becomes negative 2. Therefore, the axis of symmetry is x equals -2. For the range, we have the formula, the negative infinity, comma, k, and we use the square bracket. This k is the y-coordinate of the vertex. So we will just substitute the k. It becomes 4. The range now is negative infinity. Of course, we use the parentheses, then comma, 4, and the square bracket. Now for letter D, maximum or minimum value. The parabola opens downward, so we don't have a minimum value because the graph of parabola goes down continuously. So we have a maximum value here. And that value is equal to the k itself, and this k is that y-coordinate of the vertex. So we have k equals 4. So the maximum value is 4. Now letter E, decreasing interval. With respect to the axis of symmetry, the right side of the parabola is our decreasing interval. Do you remember? We're going to read the graph from left to right, and when it is going down, that is the decreasing interval. So this side here is the decreasing interval. And our formula is the square bracket h, comma, positive infinity, parenthesis. And this h we will now change by the x coordinate of the vertex. So the decreasing interval h becomes -2. So this is now our interval notation for the decreasing interval. For the increasing interval, that is the left side of our parabola. You see here, if you read the graph from left to right, so that is the increasing interval. And we have the formula for that. That is the parenthesis, negative infinity, comma, h, and square bracket. We will just substitute the h value with our x coordinate of the vertex. So our answer is the negative infinity up to -2. We use the square bracket here and also the parenthesis because we know every time there is infinity, always parenthesis is used. So we are now complete with our answers. I hope you learned something from this video. See you again next time.